All right, 2.7. So this is your third day without me in class. So it's Friday now. And this task, it's kind of long. The video I'm going to try and keep short. I've already written some of the things that are required for this video. And then over the weekend, you guys can start working on the Ready, Set, Go if you want. And then on Monday, I will be answering any questions that you guys had from while I was gone for those 3 days, homework questions. So come ready on Monday with questions from 2.6 and 2.7. That will be Monday. All right. So we're going to look at another way in which we use logs in the real world. And the main thing is when we're talking about how something is growing or decaying exponentially. So we have the formula that we went over in 2.6 for continuous growth. And then we're going to look at continuous decay. I have highlighted in green here a really good way that they're describing what exponential is, what E is. And E is the natural exponential function that occurs in nature. For example, if you get sick and you have a germ, how fast that germ is growing in your body. Or when something becomes deceased, how fast the body starts to decay. When we are carbon dating dinosaur bones, we are actually using this formula of decay. Carbon has a half-life, and we're able to figure out how old a bone is, or about how old a bone is. So this is all stuff that occurs in nature that we're dealing with today. So we have e to the x. Just like the logarithm and an exponential function go together, e to the x goes with what is called the natural log. But for whatever reason, it is actually called ln on your calculator. So it's probably something like the logarithm natural or something. But it is called the natural log, and they undo each other. So when I see them together, I actually get to cancel them out. For example, if I see e to the ln, so instead of x, it's to the ln, that cancels. Or if I have ln of e to the x, this cancels, and I'm left with x. So that's kind of what we're working with today. And we saw e already in 2.6. So we're going to start with a disease in the first half of our problem today. And I've highlighted the important things that we need to know because there's a lot of unnecessary information. So we are told it's continuous and that it's growing at a rate of 3% per day, so 0.03, and it has 5 victims already, and that's actually going to end up being our principal. So now, in number 1, I am asked to model this using a table, a graph, and an equation. I am actually going to write the equation first. So A equals PE to the RT. So A is going to equal 5E to the 0.03 T. I'm going to use that equation to make my table. So I'm going to get this started for you guys, but I am going to want you guys to finish it. So T and A, I'm going to plug in time. So it told me I'm starting with 5 people. So day 0, 5 people. For 1, 2, 3, 4, go to 5. This is going to be 5e to the 0.03 times 1. So in your calculator, I'm only going to show this to you once. And if you're getting confused, you're going to need to just pause it and keep practicing. Write this down if you need to. Don't write it here, though, because you're going to put your graph in this empty space. Maybe put it on a Post-it note and then stick it in your book. So in my calculator, I'm going to put 5 parentheses E. When you hit the E button, a caret automatically pops up for your exponent. If your caret pops up with a parenthesis. It's 0.03, close the parenthesis. The reason I'm only using 0.03 is because 0.03 times 1 is 0.03. Now I plug that into my calculator. Hold on, I'm plugging it in right now. Notice I have two parentheses. If when you hit the E button and you don't get a parenthesis that pops up, you only need one set. So I'm going to hit equals, and I get, I'll use a different color for my answer, 5.15 people. So a little over 5 people. Let me erase this for now. Then I'm going to move on to day 2. 5e to the 0.03 times 2. So in my calculator, this would be 5 parentheses e caret parenthesis. I would just use 0.03 times 2. Close the parentheses. So double parentheses here. So 5e, 5 parentheses e, 0.03. So I'm using parentheses again. 0.03 times 2, or just go with 0.06. It's easier. And I get 5.301. So I'm going to just go 5.31 because it's 0.9. 5.31. So it's growing a little bit. Keeps growing a little bit and a little bit and a little bit. I'm going to let you guys plot these on your own. So you guys can do 3 and 4. Now I get to 5. So this is going to be 0.03 times 5. So 5e caret 0.15. So 5e, using my calculator, and I get 5.81. You're not seeing much growth right now, so maybe you want to jump to day 7, day 8, day 9, day 10, day 11, day 12. Once you get the hang of this, or maybe go every 4 or 5 days. Maybe you want to go 1 to 7, and then 10, and then 15. When you graph this, the more points you have, the more accurate your graph is going to be. So I'm going to graph this. I'm going to put in a coordinate plane, and I'm only going to use the first quadrant. This is my days, and this is the people that are sick. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure that your graph is scaled properly, please. If you're going to go every other day, that's fine. Just 2, 4, 6, 8, 10. I would spread out my days since these are not very close together at all. Or sorry, these are not very far apart. So it might be helpful if you spread your days out, because this is growing pretty slowly. Now, once you have that done, you're going to use your equation and find how many people are going to be infected on day 30. So I'm just going to start this. So it would be 5e to the 0.03 times 30 days. Use your calculator, and B, you're going to go with 60 days. Make sure you're checking with your group as you guys are working through this, so you can make sure you're getting similar answers. And they should be pretty close, if not exact. You should be getting the exact same answers. Now, based on your model, when will there be 50 victims? That means your A equals 50. So this is going to be 50 equals 5e to the 0.03 t. We are looking for t. So I need to start by dividing by 5. You need e to be completely alone. Remember back at the beginning of the task, I showed you guys that when you see e and the ln together, the natural log, they will undo each other. So that's where I'm headed with this. So I have 10 equals e to the 0.03 t. Now, in order for me to solve for my exponent, my variable is my exponent, I have to ln both sides. Just like I would log both sides back in 2.4 and 2.5, I had to use log. Here I'm using ln. So this would be the natural log of 10 equals the natural log of e to the 0.03t. So now that's going to cancel. The ln and the e are gone. And I will then be left with the natural log of 10 equals 0.03t. Now I can divide by 0.03. And then I'm going to use my calculator. And it's the natural log of 10. And then you're going to divide, put parentheses, 0.03. Or just hit equals. I like to just hit equals. Natural log of 10, hit equals, and then hit divide by 0.03. So the natural log of 10, hit equals, divided by 0.03. And for 150 people to be infected, it's going to take 76.75 days for 150 people to be sick. Make sure you can get that in your calculator, please. You will have a problem like this on your test. Okay, be ready for this. I've already written your test for these 4 sections, so make sure you're ready for this. No quiz, just a test. Now, will the number of days it take for the virus to claim 100 victims be double the number of days that it took to claim 50 victims? So here, you answer this. What do you think? Actually, that's... Okay, you answer that, and then you're going to prove it. You're going to either prove that you're right or you're going to prove that you were wrong in number 5. So 50 people took 76 days. So the question is, will it take double that for 100 people? So I'm going to go through the same work. 100 equals 5 e to the 0.03t. So now I want you guys to go through and solve for t. Don't forget you have to use the natural log. Then you're going to go through 150 victims. So 5e to the 0.03t. Again, you're going to solve for t. And then you're going to have to use ln again. Check with your group, please, to make sure you guys are getting the same answers. Okay, that's the first part. Now we're going to move on to the second part. We're going to kind of skip around on this one, but just go with it. So now these people are turning into zombies. And it's going to grow continuously at 12% per day. And it started with 80 people. And it's going to ask you various questions. So I'm going to get you started with your equation. A equals 80e to the 0.12t. So number 7 wants it for 5 days. So you're going to plug in 5 for t. How many days will it take for the population to reach 3,700,000? Well, now your A is the 3,700,000. So you're going to plug that in for A. So from number 7, you're going to plug in the 5 for T. But for number 8, you're going to plug in the A, that 3 million for A. And then here, don't forget, you will have to use ln. And then when we get to 9, at what rate would the zombie population be growing if it reached 190,000 people in 20 days? So this is your A, this is your time. So 190,000 people, when it started with 5, just kidding, not 5, 80 e to the 0.12 times, sorry, r times 20. Getting lost with the other problem. So you're going to go through the same process, but now you're going to find r. So you're going to start by dividing by 80. And then, so first you're going to divide. Then you're going to use the ln. And then you're going to divide. So here you're dividing 80. Then you're going to use ln. And then your third step would be to divide by 20. So hopefully that helps. Check with your group. Get your answer. Share. Help each other out. Okay, now we're looking at zombie goo. We're almost done, guys. Hang in there. I know it's the scary stuff with the zombies. So, John's laughing at me. He's in the kitchen cooking dinner while I'm doing videos. So now we have a goo that is radioactive, and this one is going to decay with a half-life of 3 years. So every 3 years, this goo is going to be half of what it started with. So when I'm going over this in math analysis with them, when we're starting to talk about half-life, if I have 10 on year 0, what this means is in year 3, I'm going to have half of that at 5. At year 6, I will have half of that, which is 2.5. At year 9, I will have half of that, which is 1.25. Whoa. So this is the whole idea of half-life. Its rate is not 0.5 because of it being a half-life. This is actually a little bit more complicated than kind of what we're... It's not as easy because of the fact that it's a half-life for every 3 years, which makes finding the rate a little bit harder than what it would be in another case. So I'm not going to have us kind of... I'm just not going to have us work through this. I just want you to understand what half-life is, that we're cutting it in half every 3 years. Or if it's said every 10 years, then it would be half every 10. And we cut each amount in half, and then in half, and then in half, and then in half. And you can never get to 0. So there will always be something there. That, again, that's how we can measure dinosaur bones, their age, because there's always some carbon left that we can date. And we can say, oh, it has this much left, so it started with this much. No matter what, we all start with the 100% carbon, and then after so long, it just keeps cutting in half. So you're welcome to try plugging into the A equals PE to the negative RT, because we're talking about decay, where you would have half-life where you would then have to find the rate, because you don't know the rate. That's where these ones are tricky. It's not 0.5. It's, if I start with 10, what's half of that? Half of that is 5. So then I would have negative R. I don't know what the R is. I have no clue what the rate is. They didn't even give it to me. But I know my time is 3 years because my half-life is 3 years. So you're welcome to go through and solve this. Once you do, once you find R, then you guys can plug in your time. But you have to find the R first. So I'm not worried about you guys doing this. I will probably do this in class. This is something I would like to talk about in person. So save those unless you want to try it. You're welcome to try it. Find R. Once you find R, then you're going to plug in P is 10, Your time would be 5. You have to find R. That's what you're looking for over here first. Okay, and then once you have R, then you can answer 11. And then you can answer 12. So try it if you want, but I will be going over this with you in class. And that concludes our 2.7 task. And I am so excited to be back with you guys on Monday. Hopefully this went well and that you behaved for the sub. I'm going to have to give some knuckle sandwiches. And I will see you Monday. Have a good weekend.